Welcome to the chapter 5 of the Oil and Gas Engineering Audiobook. Now that we have defined the process equipment, we shall define the way they are arranged in the plant. This is the purpose of the plant layout. Plant layout is sometimes included under piping discipline, even though it has a very distinctive role. It defines the overall layout of the facility as well as the position of each equipment within units. The overall facility layout is primarily dictated by safety. Two means are employed to reduce the risk to the minimum possible level. The first one is to adequately select the relative positions of the various plant areas. The second one is to provide safe separation distances between these areas. A proper layout and spacing indeed can significantly reduce the consequence of a fire or an explosion. An oil and gas facility comprises process units, utility units, as well as off-sites such as storage and offloading, fire station, control room, and office buildings. Utility units are located away from process units in order that they remain operational in the event of an incident in the process unit. Manned buildings are located the furthest away from process units and in a location where personnel can easily escape the facility. The wind direction has a large influence on the layout of a facility. This may be quite surprising for the newcomer, but one has to understand that a gas cloud that could originate from a leak source would develop towards the direction where it is blown by the wind, and it must not be allowed to reach an ignition source. Therefore, ignition sources must be located upwind of possible leak sources, i.e. process units and storage areas. There are unavoidable ignition sources in oil and gas facilities. They include fired equipment such as furnaces, as well as the flare and electrical substations. The layout shown here would be an adequate layout for a land facility. As you can see, the prevailing wind is blowing from the left side. The flare has been located crosswind of process units, and the storage tanks have been located downwind of the flare. The storage tanks could also be located downhill if the relief of the site so allows. Once this overall facility layout has been decided, the relative location of the various process units must be defined. The arrangement of process units within the facility is primarily dictated by safety considerations as well. Separation distances are kept between units in order to limit the impact of a fire or explosion in one unit on the nearby units. Indeed, the radiation level from a fire or the overpressure blast from an explosion very quickly decreases with distance. A separation distance is therefore an effective means to reduce the consequence of a fire or explosion in one unit on the adjacent units. Each unit is classified in terms of level of hazard. The classification depends on the type of fluids handled in the unit, the type of process. Is it a reactive process, a reaction where there could be a runaway or not, and the level of pressure and temperature. Once each unit has been classified, a separation distance is kept between each two units by the combination of the hazard levels. For instance, two high hazard units will be separated by 60 meters, whereas two moderate hazard units will only require a 15 meters separation distance. The overall facility layout is reviewed during the hazard review session. Hazard means hazard identification. It looks at the hazards to which the plant could be subject due to its location, so due to its environment, as well as the hazards that are inherent to the plant due to its process and operations. The general plot plan shown here, for instance, was reviewed during the hazard, and the various substances were marked using different colors. During this hazard session, it was decided that the storage tanks must be relocated furthest away from process units. Once the overall facility layout has been established, layout will define the unit layout. This is primarily done according to process requirements. The position of equipment is determined according to their sequence on the process flow diagrams. The size is given by process in the process equipment list, which shows the dimensions of the equipment which result from the process sizing. Such sizing, nevertheless, only concerns vessels. Rotating equipment and heat exchangers and other types of equipment are not sized by process. Therefore, inquiries to vendors are necessary to obtain dimensions. In the case shown here, for instance, that includes a gas compressor and an air-cooled heat exchanger, inquiries will have to be made to vendors of these two equipment, the gas compressor and the air-cooled heat exchangers, to get dimensions in order for plant layout to be able to produce the unit plot plan. Note that the dimensions to be obtained from vendors of complex equipment such as packages, a turbo compressor package for instance, must include the dimensions of auxiliaries. For a turbo compressor, for instance, it must include the size of the air inlet system of the turbine, as well as fuel gas conditioning and lube oil conditioning skids. The view shown here is the plot plan view. However, process equipment must also be arranged vertically. The relative elevation of process equipment is determined by process reasons, primarily gravity flow from one equipment to the other. In this system, for instance, which is made of a column, a reflux condenser, an accumulator and a pump, the reflux condenser condenses the gas coming out of the column, and the condensed liquid flows to the accumulator, wherefrom it is pumped back to the column. Gravity flow is required between the condenser and the accumulator, while the pump needs to be located below the reflux accumulator with sufficient head so that it won't cavitate. A stacking of equipment, such as the one shown here, is required. The condensers are located above the accumulator, which itself is located above the pumps. Similarly to what was done for process units, separation distances are kept between high-risk process equipment. Only a few equipment are concerned. They include high-pressure pumps pumping flammable fluids at high pressure, high temperature, flammable gas compressors, and so on. A separation distance is kept between these two high-risk equipment as per the combination of hazard level. For example, a distance of 15 meters will be provided between a high hazard reactor and a flammable gas compressor. A separation distance is also naturally kept between an open flame furnace and the rest of the facility.
Besides process requirements, the equipment layout must take into account the access requirements for operation, escape, and maintenance. These two reactors, for example, are filled with catalyst. Every few years, the catalyst needs to be replaced. Therefore, an access for vehicles needs to be provided to replace this catalyst. Shell and tube heat exchangers are subject to frequent maintenance, which requires the removal of the tube bundle. Therefore, these heat exchangers have been located on the top level, on the top deck of this FPSO, in order to be accessible by the crane. In fact, the equipment layout for offshore facilities is strongly determined by maintenance requirements, by accessibility for maintenance. Indeed, overhead access with a crane for removal of parts is not feasible offshore as it is onshore, as equipment are stacked on several levels. Therefore, parts must be moved by means of monorails to the edge of the platform where they can be picked up by the crane. The routing of lines between equipment also impact the position of the equipment. Enough flexibility must be provided in the routing of the line connecting two equipment so that its thermal expansion will not result in excessive efforts on the equipment nozzles. This is particularly true for rotating machinery, as excessive efforts could bring to machinery misalignment.
Space must be provided for operator to access instruments and valves. For instance, one has to take into account that the operator needs to access the suction and discharge valves on the lines feeding this pump, as well as the strainer and any instruments present on these lines.
One may wonder why minimum of 3 meters is provided between these two vessels. However, once the equipment, pipes, and instrumentation has been modeled, one will quickly understand that the 3 meters was the minimum required. This shows that plant layout engineer needs a lot of experience. It indeed needs to take into account all the equipment environment, even if it is not yet designed and shown in the 3D model. allocation of space must be made for all the plant networks, including pipes, cables, escapeways, fire-water network, drainage networks, and so on. Let's look at this underground networks consolidated drawing. It shows all what is underground in a facility. You find equipment foundations, rainwater collection network, including underground pipes, catch basins and manholes at changes of direction, underground vessels, which are drain vessels, this one, connected to drain networks, which collect drains from vessels, such as this column. There are few drain networks, open drain, closed drain, sometimes they are chemical drains. Also, cables are buried underground, since it provides mechanical protection and also fire protection. So you'll find electrical cables, instrumentation cables, which are also run underground. Finally, you will also find the fire-water network, which is also buried for mechanical protection and fire protection reasons. Hence, a similar drawing showing all the underground networks has an impact on the facility layout and the equipment location. Finally, economic considerations come into play. And this is basically to reduce the lengths of pipes, cables, pipe racks, and so on.
The deliverables of the plant layout discipline include the general plot plan and the unit plot plan. The general plot plan shows the overall plant territory. It shows the location of the process and utility units, as well as the buildings, offsites, flare. It also shows the connection of the plant with its environment, such as access roads and pipelines, electrical power grid. The unit plot plan shows the positions of equipment within a particular unit. The one shown here is typical. Equipment are arranged on both sides of a central pipe rack. The central pipe rack supports the lines from one equipment to the other. It also supports the lines from the plant to the unit and from the unit to the plant, such as utility lines and process lines. Battery limit valves are located at the boundary of the unit. A peripheric road with access ways provides easy access for operation, maintenance, or emergency. Fixing the position of equipment is a major step in the design. To do this, the involvement of the plant owner, the future operator, is necessary. Therefore, a review of the plot plan is organized with the plant owner. This review is done in 3D and is called the first or 30% model review. The review is called 30% as at this stage only 30% of the lines are modeled. These are the main process lines. All the lines which are shown on the process flow diagrams. The aspects reviewed are primarily the access for operation as well as maintenance operations. The purpose of the first or 30% model review is to freeze the plot plan. Once the first model review with the plant owner has been held and any changes have been incorporated in the unit plot plan, it is issued for design, IFD. This is a major design stage. Indeed, many disciplines require the equipment layout, the unit plot plan, to be frozen to start their work. It includes piping for the routing of lines, structural steel for the design of steel structures, civil for the design of foundations and underground networks, electrical for the design of the electrical power distribution system, instrumentation for the routing of instrumentation cables, and safety for the distribution of the fire water. Nevertheless, at this stage, the unit plot plan will not be finalized. As you remember, a number of equipment are designed by vendors such as rotating equipment, fired equipment, packages, heat exchangers. The dimensions of these equipment will not be known at the stage of the issued for design plot plan. This shows the dimensions that were thought to be that of air blowers at issued for design stage of the plot plan and what they finally were when the plot plan was issued for construction. You see that significant differences can appear between these two revisions of the plot plan. Receiving equipment vendor general arrangement drawings showing equipment dimensions, as well as for packages that include several equipment and skids, receiving arrangement drawings from the vendors showing the arrangement and dimensions of all the skids and all the parts of the package is a prerequisite to freeze the plot plan and issue it in issued for construction revision. And the issue for construction of the plot plan is a prerequisite for any drawing in any discipline to be issued for construction to site. This concludes the presentation of the plant layout discipline. Thank you for your attention. Goodbye.